Hello, welcome to this video of heuristic algorithms. In this video we're going to discuss the calculation of numerical integrals, and for that purpose we're gonna review knowledge that we already have seen in previous courses. Let's start with the function f of x equals y is 4 times x squared minus 3 times x plus 5, and its corresponding integral would be 4 times x cubed divided by 3 minus 3 times x squared divided by 2 plus 5x, assuming that we are interested in defined integral. So I have prepared these tables with the following information. This would be the domain of x, and we're going to vary it from 0 to 1.25 in steps of 1/8, and we can compute the value of f of x, and we have here the formulas. It's the same formula, just making reference to a different cell, the corresponding domain. And then we have the formula to compute the substitution of x with these corresponding values of the domain, specifically as depicted in the first column. And as we know, the area under the curve that we would be interested can be computed as the difference between specific points in the domain. We're particularly interested in this example on finding the integral from 0.5 to 1. So what we need is to subtract from 4.833, that is the capital F of x of 1. We're going to subtract from that the capital F of x when x equals 0.5, and that value is 2.92. I have extracted these two values here for clarity, and the difference between these two is 2.5416. But this would be the traditional approach with calculus. So now we're gonna prepare the computations of these using a numerical approach. For that, we go to the definition of what integral is, and it's nothing but the sum of f of x times the x when the x is a small value, and that is for x equals from x1 to x2, and that's what it is. It's just the sum of many small areas defined by this product when the base dx is very tiny. Again, we're talking about the original definition. So let's consider dx that it's tiny. We're not going to go very small, so we're going to have a larger numerical error, but this is for the sake of the example, and we're going to have 0.00. Okay, let's start with 0.01. So it's just 1 over 100. It's not very small, but still, what we could do is we can multiply. We can have the value of x and start at well, we're interested in finding values starting at 1, and then the next value of x is going to be just that 1 times 1 plus the dx. That's going to be the new value of x. And if we're interested in finding the integral, this should have been started at 0.5. And if we're interested in finding the integral, we make this computation until we reach 1. There you go. So if we get all into 1, that would be enough. And we copy the formula for f of x. And we have f of x for all these values. And now we multiply in a very simplistic way f of x times the we need to make an absolute reference to that before copying the cell. There we go. And if we add all these numbers all the way to 1, the approximation that we obtain is 2.59. Let me separate that number here. And this is the number that we need to compare to 2.54. Now, of course, we're not getting an exact number because this dx is rather large. We will get a much better approximation with a smaller number. So we can go like that. Of course, that means that now our spreadsheet is not long enough, and we need to extend these results all the way down now until we get 1,000, or rather about 500. Those are extra, so we can compute that sum now to, as you can see, now these two numbers are closer. It used to be 2.59, now it's 2.54, and so on and so forth. If we keep reducing this number to smaller and smaller quantities, it's going to approach better to the right solution. So this is how we do numerical integration. Of course, we can compute this in this fashion, the area under the curve for a particular function, without having to solve analytically what the integral is. And this is how many of the functions in probability, in the tables that you have in the back of the book of your probability courses, are computed based on some numerical integration type of way. This column is then f of x times dx. Right, this should have been f of x. Right, thank you very much. See you next video.